So we're here at the IP500 Alliance.
Yes.
And who are you?
I'm the chairman of the Alliance and the CEO. I'm acting as operational body here in out of Berlin. Our headquarters is in Berlin located, and our OEMs, basically our members, are international huge organizations.
So what is IP500 wireless network? What's going on here? Is this for the Internet of Things?
Yes, we basically started about 7 years ago by discovering that there is a missing spot, that we discovered that the top down situation is not basically met by bottom-up solutions. That means we have bought existing products, I don't want to call names, but modules which are basically not interoperable with each other. So we basically found out that if you go top-down and make a product from the application point of view, then we can basically meet the interoperability of this building, for instance.
Interoperability of wireless networks, is that it?
Yes, basically we are talking about wireless networks.
Which kind of wireless? Is it Wi-Fi?
We are talking about here the smoke detectors, for instance, and the most important part is this kind of detectors, smoke detectors, wearables. We have basically also kind of only simple products which go into a door, like for instance. And you have to understand that all of them have to basically work with each other. Like a smoke detector with a mobile device, or with a door lock, which I don't have, but that could be also put in a door lock. So basically, the problem was in the last days or in the last years that we basically discovered that the interoperability has to be put on from top-down approach. So you have to understand the applications from a building. If we may go here, you have to understand the applications from a gateway point of view, smoke detector point of view, maybe a smart grid point of view, because all the requirements are different. So we started as a top-down approach, saying what do we need, what do we actually have to meet, instead of making a product like a wireless sensor and install it. At the end of the day, you have discovered that this, let me say, heating system is not working with a smoke detector because there are missing pieces.
So it says here wireless mesh networks for security applications, but so is this Wi-Fi, Bluetooth? Is it something else?
Yeah, that's a good question. Wi-Fi is for high data rate, as we know, right? High data rate are basically for video, for data communications, like for PCs, but smoke detectors have different requirements. There are norms, regulations in Europe. Worldwide, UL is a name, VDS is a name, is a regulation. UN regulations are very critical for such a product. So wireless mesh networking communication needs to meet all of that requirements. So we are talking about light systems, we are talking about smoke detection systems, and we're talking about different kind of heating systems. And IP500 has met all of them together in a single spec, and then have asked suppliers like Connetics. Like we see Connetics here. They actually are the supplier of our module, which you see here. It's basically the module is IP500 module. This is the result, and that's basically a access point kind of, right? It's a development kit which basically makes the connectivity to the individual products. So what you have seen here is kind of a gateway here. We can also connect that to the GPRS world, and that requires, of course, connectivity from the GPRS world into the IP500, which you basically see one of the examples here. So
you're talking about sub-gigahertz? Is that what it is? Is it like the white space area or something like that?
No, sub-gigahertz is basically the 868 or 915 band. From worldwide perspective point of view, this is 720, something like that, to 980, because different countries have different, basically, frequency bands.
So is that licensed or unlicensed?
This is unlicensed ISM band.
That was what was a TV before?
A part was of the TV before, but we took the already existent ISM bands, which is basically 868 in Europe and 915 in US, for instance. And for instance, in Japan it's 920. So we put all of that into our specification, as we said. From the wireless point of view, we have taken IPv6 protocols which basically gives you the ability to give every single device, Internet of Things, a address, a unique address, right? We took on top of that also protocol stacks, protocols like BACnet over IP. So we put all this together, and basically when you see here that in a diagram, that's basically the full chain here. This is the OC layer, and you see we go far from to the top, from the physical layer over the transport layer to the protocol layer, which basically is the IP500 solution. And that's basically here you see this is basically the hardware, and that's basically the diagram of the entire thing.
So is the IP500 Alliance.org, how many people are using it right now?
Oh, we have the major players like Honeywell, Tyco, Siemens, Bosch, UTC, you name it, from the building automation. And basically what is really interesting, this hall, for instance, hall is our target marketplace. In the old days, or in the previous days, and even today, you can see a lot of alliance like the Zigbee Alliance, like the Thread Alliance, like Z-Wave. They are basically focused on home. We basically address that building here because that building has a different character. Here we are talking about 10,000 of sensors, not only hundreds or even 10. We are talking about 10,000 of sensors. So all the major players, again, as I said, Dorma, for instance, or other big Schindler, the elevator guys are members of us in our alliance, and they are basically deploying our products into their systems.
So does that mean that all the products are using this frequency and this system right now, or some of them are using different?
I would wish that all of them will use it at once, but step by step, that's the secret here. Some of them are using it today, and some of them are building that in future. What we are doing now is smart cities. We are organizing smart cities and smart facilities. So basically what we are doing is we are integrating that module into the products and going into a live showcase or into live projects where we demonstrate the interoperability between, for instance, a motion detector, as I said, the smoke detector, and, for instance, a mobile detector. So all of that is happening right now, and we are deploying that into the smart city projects.
So Internet of Things is a crazy big industry,
Sure.
and there's a lot of things are happening right now.
Yes.
So is this going to be the whole world that's going to be using this?
Well, I would say yes. Why? Because you have to start with the highest performance or most critical devices. As I said, if you go with a truck from North Germany to South Germany, or from North Japan or England to South England, you have to be careful of the lowest bridges. So the lowest bridges in our world are the security safety devices. So we understand that we are the only alliance supplying this module into such a product, right? Which basically gives you the chance to interoperate with our solution. That means security, physical security, is the top issue and topic in this IoT. And believe it or not, if you look around, there is none other alliance which supplies a product, again, a module which can be deployed and built into a smoke detector, and likewise in a door, for instance.
Is the Thread Alliance incompatible with what you're doing? Is it a different thing, or could be the same?
The Thread Alliance is basically, first of all, focused on home. It's 2.4 gigahertz. 2.4 gigahertz is not going to work in this hall. Again, I'm putting home in one basket and commercial building in another. But what we can do with sub-gigahertz applications and sub-gigahertz communication, we basically can go from a commercial building into a home. So with Thread Alliance, we are using the same mechanism, by the way. 6LoWPAN 6LoWPAN is also meshing, asynchronous meshing. We do share, of course, some of the application which we use here, and we do share some of the IEEE. However, they are using, as I said, 2.4, and we are sub-gigahertz, and we have the dual band. This is basically the newest product which we released by Connetics again. These are our suppliers. This is the world first dual band for security application in the IoT world. So basically that's the product you see here, which basically addresses both bands.
Does it use an ARM processor? How does it work?
Well, ARM processors are everywhere. When you see in a microcontroller, we do use microcontrollers, and yes, we can use and we do use ARM processors.
All right. And so people to use this, they have to buy the hardware, they have to just join the alliance. Well, how does it work? Is there a price, or how does it work?
Yeah, sure. Well, we kind of also protect our business model to make the interoperability work. How you do this is you create an alliance. You join as a member. As a member, you pay 8,000 euros per year. By the way, that's just a fee that feeds our alliance. By the way, it's basically the money to operate the alliance, and then you are able to access all the documents, all the hardware, and work with our suppliers on building your products.
And you can also use any other supplier. You can use any hardware maker, or how does it work?
Yeah. Well, first of all, let me start with that. We have chosen basically Connetics, Atmel, for instance. We have chosen EBV, TÜV Rheinland as a supplier, as a provider of services and of products. And in about 1 or 2 years from now, we're going to open that to other partners because our most precious core issue is interoperability, and you secure that interoperability by making that alliance work in a fashion that you have your partners set, you have your specifications set, and then you go with the first products into the market and expand that into other applications.
So security, is that a lot of encryption and provisioning, or what's the trick for making sure the building isn't taken over by somebody else?
Yeah, that's basically what you said. It's a three-layer security application or issue. When you go here, we have security in the hardware, right, in the physical layer by mechanism we built in. We have security by ISA 120, and we have security also at the application layer we have built in. Because we are using several protocol stacks which are making security work. So basically you have security at all three layers in our application.
So is it 100% secure, or people can still hack it?
Well, you have never 100% secure because it's a matter of time. As we all know, everybody can
hack old devices. But then you update them remotely?
Yes. Again, we have different mechanisms. If you want to break into an house, you need time also, right? So I think our system, and I believe, and we have tested that, is pretty much secure that you cannot actually really break into this kind of network within a certain time.
All right.